Good morning, everyone. My name is Felipe Mion, and I have the pleasure of leading government go-to-market at OpenAI. I'm joined with Mohammed Hussein, who is a solutions engineer on our team. OpenAI is working at the frontier of AI to bring it to hundreds of millions of people in both a research capacity and then a deployment capacity by building products. I'm going to tell you very quickly about our government products, and then we're going to spend most of this time showing you the tools. So at OpenAI, we make the cutting-edge frontier models. So models like GPT-4o, 4.5, our O reasoning series of models. And then we expose those to customers in a couple of different capacities. First is in an API product, where developers access our models to build their own products. And then we have a first-party product, ChatGPT. And for governments, we work with government agencies. We have a ChatGPT enterprise product, the full software as a service. We then have a relationship with Microsoft where they're able to access our IP and are able to copy and paste it and run it in their own product that they call Azure OpenAI. Azure OpenAI, Microsoft has moved into their government cloud, so you can run it at IL5, IL6, IL7. And so what we have done is actually taking the first-party product, ChatGPT, and rebuilt it on top of the Azure OpenAI so that you are able to run it in an IL5, IL6, IL7 accredited way. And that's what we call our ChatGPT Gov product. So with that, we're going ahead and show you some of the demos.
Awesome. Hey, everyone. Mohammed Hussein here. I'm an engineer with OpenAI. I'm going to do a few demos today. Three key themes that I want to tackle as part of our demo. Let me see if I can blow this up. First is pace of research. So everything you're going to see today represents about 9 to 12 months of frontier research for OpenAI. So just commenting on the speed at which we're deploying better models that are both foundationally very, very good, as well as applying the reasoning paradigm. Second point I want to make is about generalizability. So we're running on chatgpt.com production, so everybody can try these demos today. And the idea is that these models are so high intelligence and trained on such a wide variety of data that they're able to be usefully applied to a number of different missions, from cybersecurity to image localization to analytical research. And the third piece is, I'm blanking on the third piece, but I'm going to come back to that once I remember what that third piece is. So let's go ahead and just jump in with the first example. So this is using GPT-4o, our flagship model. And so what I'm going to first ask the model to do is I'm going to upload the Conti data set. And the first prompt I'm going to say is the following. I want you to assume the role of a cybersecurity analyst. I want you to go through these text messages and metadata, and I want you to create a comprehensive dictionary that translates the covert slang and workaround terms into plain language. So what you can see here is, I also say, focus on words that suggest locations, systems, key actors. You can see here that, this model wasn't explicitly trained to be, a cybersecurity-focused model. This is a base model. But you can see that the model is able to recognize the context of the task and do things like invoke code interpreter, hit certain roadblocks in its analysis, re-invoke code interpreter to go through new paths. So even though we hadn't released agentic capabilities, we start to see evidence of this agent-based workflow as early as summer of last year. So what you see here is it's going through this data, it's sampling a couple of different lines, and after a few seconds, it's able to come up with a preliminary dictionary of covert terms. I have now remembered what that third thing was, and it was about scaling impact, right? So we don't see these models as supplanting individuals. We see it as scaling the amount of data that an intel officer can go through, or scaling the amount of information that a logistics officer or cyber officer is able to go through. And we see that as a great example here. If I scroll back up, you see this is about 60,000 text messages that I uploaded, again, on our commercial instance with a 12-month-old or 9-month-old model in a different language. And it's able to provide that sort of baseline analysis in just a few seconds. One of the things we saw in the first time we ran this demo was its ability to pick up on this term. So I don't know if anyone speaks Russian, but this term means toad. And the model is able to identify this as an anomalous term within the context of this data set and determine, here are the different indications of where this term came up, and it likely refers to this, Jabber protocol. So just an example, again, older model, but able to complete a very, very hard cybersecurity task, something that our analysts are likely able to do themselves, but giving them the ability to rapidly triage that data and save more time for the what if and the critical thinking. So that's demo one of three. I'm going to go through another example where we're going to introduce the reasoning paradigm, and there's actually going to be a little audience participation on this one. So with the reasoning paradigm, we introduced this last fall. The critical thing that's coming here is what Kahneman referred to as type 2 versus type 1 thinking. So whereas these models were optimized to provide responses as quickly as possible, with the reasoning paradigm, we trade off that instant response with giving the model effectively time to think, and thus producing a much more rich and informed answer. And so for this example, what I'm going to do is I'm going to upload an image of a place in the world, and I'm going to ask the model, I want you to assume the role of an OSINT analyst. I want you to guess where in the world this photo was taken, right? So you're going to see here is the model's not going to come back with a response right away. It's going to start thinking. In a few seconds, we'll see that sort of reasoning modal. But what I'm going to do is I'm actually going to pull it up, and I want to see, given we have so many defense specialists in the room, if anyone could shout out a country at minimum, followed by city, and ideally where in the world specifically this was taken. So maybe 15 seconds, take a look, and if you have any ideas, just go ahead and shout them out. Vietnam, okay. Not Cambodia.
Vietnam's correct.
Vietnam's correct. Any cities? Ho Chi Minh, okay. 5 seconds, any specific building? Close. This is actually the reunification palace in Ho Chi Minh, which if we give the model, there you go, it's able to come up with that. So what are the clues that the model used? It's probably similar to the clues that you guys used. So using the large red banner, the national flag, the surrounding architecture, contextual signage, traffic orientation, driving on the right side of the road, and then coming up with the location. So again, certainly not an expected use case for these models, but something that surprised me as someone who, I literally wrote a research proposal on this very specific task of image localization, geospatially consistent models. And here we have a model that, just by nature of the intelligence and the reasoning paradigm, is able to guess where in the world this photo was taken. So really sort of a remarkable jump in also showing the capabilities on the multimodal side as well. Third and final demo I want to show is deep research, probably our most exciting development. And so what I'm going to do is I'm going to give the model the following task. I want it to focus on PRC efforts to establish rare earth mineral supply chains in Central Asia, the Middle East, and Latin America. I want it to cover partnerships, financial models, security implications, alignment with other strategic directives, leadership commentary, and I wanted to put it in the form of an analytical summary. And so I talked a little bit about that reasoning where we don't get a response right away, right? And you see that, in this example, it actually didn't start producing information right away. It says, before I begin, can you clarify time frame, depth of research? So just as if an intel officer was given this hard analytical task of correlating all this information, we see that sort of behavior with these models as well. So what I'm going to say is use your best judgment. And it's going to start. So deep research is our latest and probably best agent capability in ChatGPT. It combines our best reasoning models, frontier research in tool use, and agentic behavior where it's able to develop plans, execute on those plans, identify roadblocks and circumvent those roadblocks, and do very, very detailed analytical research over a horizon of tens of minutes, right? So again, trading off that instant response for a much more informed response. So what we're going to see here is it's actually going to take a little bit of time to run. So what I'm going to do is I'm going to jump over to when I ran it earlier, and I'm going to show you an example of what that looks like. So you can see it's quite a bit of information. But over the course of 14 minutes, looking at 32 sources, we can see here that what we call the chain of thought. So what did the model go through? What data sources did it use? What roadblocks did it identify? How did it circumvent those roadblocks? And again, the sources that it used. So if you wanted to specifically look at certain sources or not, we have the ability to steer those as well. So I'll sort of just briefly scroll. I'm at the 30-second mark, so I'm going to move a little quickly. But again, the ability to do very, very comprehensive research. We've seen a shocking amount of adoption, more than we expected on the enterprise side, on the startup side, and on the government side. And as we think about where we want to go in 2025, deep research is definitely the tip of the spear of where we want governments and agencies to be using and adopting our products. So I'll sort of just slowly, I'm going to, I guess, quickly scroll, but kind of cover those 3 points again, right? So talked a little bit about pace of research, so 12 months of research in about 10 minutes. what we demonstrated today. Second point is generalizability, so research, cybersecurity, image localization, all running on our commercial instance, so nothing fine-tuned here. Try it for yourself. And then the third piece being scale of impact. So being able to 10x, 100x, 1,000x, the amount of data that our officers and analysts are able to go through. So with that, I'm at time. So you can see here it is an unbelievable amount of information. But if you're interested in reading it, feel free to chat with us after. Thanks.